integration, and we've used this specific rule which you also learned in methods. So today, linear integration and this. Okay, so here is a linear integration question. It's worded differently. It says antiderivative, which is, hopefully you know, is the same as integration, yes? So it's giving you a clue, use substitution to determine the antiderivative or the integral. All right, so let's have a look. I'll do the same steps as last time. Let u equal to the stuff inside the brackets. U dx, so same step. Du equals dx. Okay, but if we substitute this and this in, is it going to be an easy integration? In the chat, what do you think? It's not just one straightforward like the other ones. You have to do something extra. So the things outside the brackets, we want to also integrate that. So we're going to use this equation here, and we're going to change it slightly. So I'm going to rearrange so x is by itself. So this thing is by itself. Okay, so now I've got a third substitution for this. So this one becomes u plus 2. This one is u here to the power of 5 over 2. And the dx becomes du. Okay, so why did I do all of that? Hopefully in the next step it'll become clear. Don't forget the equal signs. So I'm going to multiply this, so u to the 5 over 2, by each of these things. So the distribution law from grade 9 maths. So u to the power of 1 times u to the power of 5 over 2. What's that? We add the powers when we multiply the same base. So it becomes 7 over 2. And then we're going to multiply the 2 by the u to the power of 5. So hopefully you can see now that because they're separated by a plus, the integration is a lot easier now. We add 1 to the power. So it becomes 9 over 2. And then we divide by that power. So when you divide by a fraction, you flip it. So it becomes 2 over 9 out the front. Very good, it becomes 7 over 2. Then we divide by that power. And there's a 2 out the front, so it becomes 4 over 7. It was finding in terms of x. We substitute what u is in terms of x back in. So 2 over 9 brackets x minus 2. So it becomes quite a long expression. Is there any questions about any of that? Because it may have been a bit confusing. Yes. If a line has a gradient given by that, what does that mean? So the derivative. So that passes through the origin helps us to find the plus c. Okay, so once we've established this from the wording, we can rearrange to find the original equation, or the equation of the line, I should say. and dy becomes y. Okay, and then use that all those steps I showed you before. Let u equal to this, etc. to solve for the equation. When you get a plus c, you can eliminate it by substituting in x equals 0, y equals 0, and that'll give you the c value. Okay? I might just leave it there for today.